Alright guys, this is me going through the chapter 6 practice test. So this practice test starts with graphing some rational functions, which is, I know, the first thing that we did for the unit, so um, might be hard to remember. So alright, so just so we know, domain, x variables, range, y variables. VA stands for the vertical asymptote. Horizontal asymptote is for HA. Okay. Um, Domain and vertical asymptote will be very similar. Range and horizontal asymptote, again, those will be very similar. So let's review just a little bit the format of these right here. So y is equal to a divided by k minus h plus k. So this is the standard form of a rational function. Um, X minus h indicates the uh, horizontal translation left and right. Plus k indicates the vertical translation up or down, and a is the stretch, or if it's negative, the reflection. So in this case right here, it's just x, so there is no shift left or right. So for me, that means I am drawing my asymptotes, my vertical asymptote at x equals 0. So here's the line x is equal to 0, because that's where it crosses the axis right there. And it says minus 2, so that's a shift down 2. So that's where my horizontal asymptote. So I'm going to come up here, and for vertical asymptote, I'm going to say my vertical asymptote is at x equals 0. My horizontal asymptote is at y equals negative 2. Now, the domain is going to be everywhere except x cannot equal 0. So the domain of the function will span all the domain of x. It will go through all values of x, but except 0, because that is where it's broken up by the asymptote. And the range, so my function will span all y values except at negative 2, because that is where the asymptote is. So for the range, we'll just say that y cannot equal negative 2. And now for the actual graph. So the parent function of 1 divided by x, that has points here and here. Now if it was shifted, it would have points here and here, but because it's being stretched by 4, I'm going to take this point and stretch it up 4 units from the x-axis, because right now the distance is 1, so I'm going to stretch it away by 4 units. Sorry, not from the x-axis, but from its asymptote, and that's the same with this point here. So that's going to be 1, 2, 3, so over 1, and then up 1, 2, 3, 4, so that's going to be where my first point is. And then I'll do the same thing with this point here. Going to move, it is 1, but now I'm going to go down 3 more to make it a distance of 4. So 1, 2, 3, 4 right there. Okay, and since these functions have inverse relation, because I went over 1 and up 4, I'm going to go up 1 and over 4 in both of those directions. So up 1 and over 4, so right here, and then I'll go down 1 and over 4. So right there. So those are 2 points, and that's good. Now, just because I know that between 4 is 2, so because I went over 1, 4, down 1, over 4, I know that there's going to be a point here, over 2, and left 2. You can also add in those points. That's usually because 4 divided by 2. So let's say I plug in 2 into this function. 4 divided by 2 is 2, and 2 minus 2 is 0. So the point will be at 2, 0. And if I plug in negative 2, so right here, I'll plug in negative 2. 4 divided by negative 2 is negative 2, and negative 2 minus 2 is negative 4. So negative 2, negative 4. Okay, so if it's an even number on top, it's usually easy to pick the number that's in between. Okay. Alright, so now I'm just going to draw my branches. So here's one branch. Okay, going through my points. Like that. And because A is positive, the branches will be in the upper right and bottom left. If it were negative, well, let's go ahead and look at number 2 and see how that goes. So I know the negative's right here. If that bothers you, you can just put the negative so it's like that. Doesn't really matter. Okay, so -4, and I'm going to first look to my translation. So this is +2, so that's the horizontal translation, but we always read the horizontal translations in the opposite according to the sign. So instead of plus, we're going to go to -2. So there's that horizontal translation. So there's going to be the vertical asymptote, and the horizontal asymptote is going to be up 1. So right here. Okay, there we go. So we have those, and so with that being said, the vertical asymptote is at x equals -2. The horizontal asymptote is at y equals 1. So that means the domain x cannot equal -2 and y cannot equal 1, because that's where the asymptotes are. And we have -4. The negative just means that we're going to be in the upper left and bottom right, so opposite to what we had here. And it looks like it's the same stretch. So for me, I'm just going to do over 1 and up 1, 2, 3, 4. Up 1 and over 1, 2, 3, 4. I'm going to put in that point right there, 2, over 2 and up 2. And I'm going to reflect those into this part as well, following the same pattern. So over 1 and down 1, 2, 3, 4. And then down 1, over 1, 2, 3, 4. And then over 2, over down 2. And there you go. So that's what it would look like if you had to reflect it. Okay. Let's try this one right here. So for this one right here, there's two things you can do. So for the vertical asymptote, it just depends on the denominator. So again, this is just going to be left 1. So it's going to be right there. And if I have an x in the numerator and the denominator, like I do in these two problems, then the horizontal asymptote is going to be y is equal to the leading coefficient in the numerator, which is 2, divided by the leading coefficient in the denominator, which is 1. So it's going to be equal to 2. So y equals 2. Okay, so there you go. So that's so the vertical asymptote is that x equals -1, so that means x cannot equal -1, and this means that y is equal to 2, and the range is y cannot equal 2. Now what you can do is you can plug in values that are probably close, so you can plug in maybe 0, you can plug in -2 in here, and then you can plug in something towards the ends over here, into here. That being said, if you use synthetic division, that's preferred. So using synthetic division, I look to my denominator, and I use the opposite number that's here as a box number, so -1, and then I use my coefficients in my numerator, draw my line, drop down the 2, multiply the 2 by the -1, that gives me -2, and then I add these together, so that's going to give me positive 3 right there. Okay, and my answer, this is my remainder, this is my answer. Okay, so essentially what we have just found is that this rational expression can be simplified to be 2 plus 3, which is my remainder, over x plus 1. So these are equivalent rational expressions, just this one's written in two different ones. Okay, so again, but you can already see that we're up 2, which is where we said the asymptote was, or left 1. So this is my preferred method. I don't like plugging in numbers here and all that. So my first thing, if I were you guys, I would just use synthetic division like I did here and rewrite the function. And so this is the same format as up here. It's just that the number is on the left side, but if I wanted to, I could just go ahead and put it over here instead. Okay, so there you go. So with that being said, we already have the left 1 and up 2. This stretches by 3, so that just means that and it's positive, so I'm going to be in the upper right and bottom left. But since the stretch is 3, I'm going to go up 1. Instead of going over 1 and up 1, I'm going over 1 and up 3. So over 1 and up 1, 2, 1, 2, 3. And then use the inverse of that. I'll go up 1 and over 3. So up 1 and 1, 2, 3. And then I'll reflect those into this quadrant. So that's going to be down 1 and over 1, 2, 3, over 1 and down 1, 2, 3. So there, and right there. And that should be good. Just go ahead and bend it towards your asymptotes. Okay, there you go. Okay, so again, I'm going to do the same thing. I'm going to use synthetic division. So use the opposite number that's given there. So we have 4. So 4, positive 4, and then we have negative 2 and positive 5. We're going to drop the negative 2, multiply it by the 4, that's negative 8. Add 5 and negative 8, that's negative 3. So my answer is negative 2 plus, you can say negative 3 over the denominator x minus 4. So I'm down 2 and I'm left right 4. So down 2, that's going to be my horizontal asymptote, and I'm right 4. That's going to be my vertical asymptote. So x equals 4, y is equal to negative 2, so y cannot equal negative 2, and x cannot equal 4. You can see that I have a negative number here, so I'm going to be in the upper left and bottom right, and stretch by 3, so over 1 and up 1, 2, 3, up 1 and over 1, 1, 2, 3, and then just reflect those into the other part of that, so down 1, over 3, over 1, and down 3, and there you go. Okay, so that's graphing. Alright, simplifying rational expressions. So in this case right here, there's no, this is all one term, so one monomial, just with two different variables and constants. So these ones are pretty easy. You just have to simplify constants, variables, and variables. So 54 and 12, I believe that they are both divisible by, let's see, both divisible by 6, I believe. So 54 divided by 6 is going to be 9. And then 12 divided by 6 is 2. So 9 halves. And then x to the 7th and x to the 5th. So x to the 7th minus 5 is going to give me x squared. So that's going to be in the numerator. And y to the 4th minus to the 7th, that's going to be y to the negative 3. So if I just put that in the denominator, it's going to be positive. So y to the 3rd. And there you go. There's that. For 6, to simplify these expressions, I can see that they're both quadratics. Now, there is a typo here. That should be 13x, not 11x. So, quadratics, let's factor these right here. So if I factor this numerator, I need two numbers that multiply to be negative 5 and add to be 2. So I think that's going to be x plus 7 and x minus 5. And then here I need two numbers that multiply to be 42 and add to be 13. So that should be x. That should be plus 7 and x plus 6. Plus 7. Okay, and because these are being multiplied, I can go ahead and cancel those common factors. So I get x minus 5 divided by x plus 6. Okay, for 7, again, I'm just going to, I see that I'm multiplying, which really doesn't mean too much to me with rational expressions. So I can just write it all as one rational expression, and then I can do the same thing that I did up here. But I just need to factor everything that I see. So that can't be factored, but all three of these can be factored, so I'm going to factor them. So I need two numbers that multiply to be 6 and add to be negative 5. So I still have n minus 2 on the numerator, but then I'll have n minus 2 and n minus 3, because those add to be negative 5 but multiply to be positive 6. And then I can take out a 4 here, or even an 8 maybe. So 56 divided by 8 is 7. So then I can take out 8, and I'd have n minus 7. Okay, and then on top over here, I need two numbers that multiply to be negative 63 and add to be 2. So 63 is divisible by 9. So 63 divided by 9 is 7. So n minus 7 and n plus 9. That should do it. Okay, and now I'm just going to cancel factors. So there's an n minus 9, n minus 7, n minus 7, n minus 2, n minus 2. And I think what I'll be left with is n plus 9 divided by n minus 3 times by 8. There you go. Alright, same thing here. It's already being multiplied, so then I'm thinking that I'm just going to combine it as 1. I'm going to factor these right here. So greatest common factor there is 3n. So I'm going to take out a 3n, and I'm going to be left with 3n plus 5. And then here I can take out an 8n, and then I would have n minus 3, I believe. All over, I can take out a 2n squared here, so 2n squared, and I'm going to have n minus 3. And then here I can take out an 8, I believe, 8n. So take out 8n, and I'd be left with 3n plus 5. Alright, now let's see what factors can cancel. So 3n plus 5, 3n plus 5. I have 8n and 8n. I have n minus 3, n minus 3. So I think I have 3n over 2n squared, but n and n squared can simplify to be 3 over 2n. There you go. Alright, for number 9, factoring all three of these, but this is division. So also you can do a keep, change, and flip. So we'll do a keep, change, and flip for this one. Okay, so let's factor as we do the keep, change, flip. So this one's going to be kept, but I'm going to factor that. That's going to be 7 and x plus 4 all over two numbers that multiply to be negative 21 and add to be negative 4. So it's going to be x minus 7 and x plus 3. I'm going to multiply. Now I am going to flip these, so this is going to be on top, that's going to be on the bottom. Okay, and so I'm going to have on top two numbers that multiply to be 24 and add to be 11, so it's going to be x plus 8 and x plus 3. And then on the bottom, I need two numbers that multiply to be 32 and add to be 12. That's going to be x plus 8 and x plus 4. And now that's multiplying just like it is up here. We're just going to combine it as one rational expression being multiplied. And then I'm going to take out like terms. So x plus 4, x plus 4, x plus 8, x plus 8, x plus 3, x plus 3. And I'm just going to be left with 7 over x minus 7. And that should be it right there. Okay, same thing, it's dividing, so I'm going to use a keep, change, flip, but I'm going to factor as I go. So I'm going to turn this into two numbers that add to be 9, or multiply to be 9 and add to be 10, so that's 9 and 1. And then I have a p plus 1. I'm going to multiply, and this is going to go on top, so that's going to be two numbers that multiply to be 60 and add to be 16. That one's pretty easy, 6 and 10. And then I'm going to need the bottom, two numbers that multiply to be 90 and add to be 19. And again, that's pretty easy, 9 and 10. And then one rational expression. So p plus 9, p plus 9, p plus 1, p plus 1, p plus 10, p plus 10. So it looks like I'm only going to be left with p plus 6. Okay. Alright. Simplify each sum or difference. Alright, so I'm just looking to get a common denominator essentially with this sum and these differences. Now, so when I look at this denominator is 2x times by x, and this is 3x. So pretty much I want x squared because this is x squared, so all I need to do is multiply this by x. And I also want a common denominator between the constants, so I'm going to multiply this side by 2 and this one by 3. And that's all I need to do to get a common denominator. So if I multiply this by 3, I'm going to get 6x squared. If I multiply this by 2x, I'm going to get 6x squared. So my common denominator is 6x squared. And then over here, I have 3 times 7. That's going to be 21, I believe. Plus 4 times 2x. That's going to be 8x. And that's all you can do there. You cannot cancel these x's out because it's being added to this 21. So we can't do that right there. So that should be it. Okay, over here, there's nothing I can do to really get a common denominator other than multiplying top and bottom by the whole binomial. So n minus 5 and n minus 5. So multiply those together. Okay, so my common denominator is n minus 3 and n minus 5. Okay, and now I'm going to have to distribute those. Okay, so I'm going to get 4n minus 20 plus 6n minus 18. And then I'm just going to combine like terms on the numerator. So it looks like I have 10n, and then it looks like I have minus 38 divided by n minus 3 and n minus 5. You could factor this right here, take out the greatest common factor, but you won't get anything that's going to cancel with this, so you can just leave it like that. Okay, so this one's subtraction, but still no different. So because I see this quadratic right here, difference of squares, I'm going to factor that. So x plus 9 and x minus 9. Now the reason why you want to factor this is because I do not want to multiply this by x squared minus 81. Do not want to do that. If I do that and multiply this side by x plus 9, it's going to be very, very ugly. Because if I factor it, I can see that this already has x plus 9, which is the same factor over here. So to get a common denominator, all I need to do is multiply this by x minus 9 and x minus 9. So that's all I need to do to get a common denominator. So my common denominator is x minus 9 and x plus 9. I'll distribute that 3. Make sure you make that negative. So that's going to be 3x minus 27, and then minus 13. And then I combine like terms on the numerator. So 3x minus 40 divided by x minus 9 and x plus 9. There you go. I think that's all you can do there. Okay, again we have subtraction. Before, like I said before, I am not going to multiply this side by x squared minus 8x plus 12 and this by x minus 2. It takes way too much time. I'm going to bet that this has a factor of x minus 2. So let me factor and just verify that. So I need two numbers that multiply to be 12 and add to be negative 8. So that's going to be x minus 6 and x minus 2, and sure enough, there you go. You can see that this is composed of x minus 2. So all I need to do to get a common denominator is multiply this by x minus 6. So when I do that, make sure that you mark this as negative 3. Okay, and then I have a common denominator of x minus 6 and x minus 2. And then I'm going to distribute this negative 3 to those terms right there. But I do have x squared plus 8x minus 32 minus 3x plus 18 whenever I FOIL that through. And when I combine like terms, I get x squared, 8x and negative 3x is positive 5x, negative 32 and 18 is going to give me negative 14. And divided by x minus 6 and x minus 2. Okay, now just to verify, I think this can factor right here, so I'm going to factor that. So I'm going to factor out an x. So two numbers that multiply to be negative 4, negative 14, and positive 5. So that sounds like positive 7 and x minus 2. And then I have x minus 6 and I have x minus 2. And so that's going to cancel right there. So I'm going to have x plus 7 and x minus 6. And there you go. Alright, let's try complex fractions. Okay, so complex fractions, the thing about these ones is that you need to deal with the addition part first, and then you can deal with the division and multiplication. So addition parts first. So I'm going to add these. I'm going to add these. So instead of having 2, I want 1 rational expression. Instead of having 2 rational expressions, I want 1 rational expression. So to get a common denominator, it looks like I got to multiply that by 25 and multiply that by x. Multiply by 25, multiply that by x. But that's going to give me a common denominator of 25x, and I'll have 3x plus 75 divided by 3 over x. And now I'm going to do the division part, which is just the keep, change, flip. So keep, change to multiplication, and flip this one. So I'm going to factor that 3 out of there, though. So it's going to be 3x plus 25 divided by 25x. And then multiplied by x divided by 3. So flipping that one right there. And then I'm going to cancel any terms because now it's multiplication. So now it's multiplication. So I can cancel an x and an x, a 3 and a 3. So I have x plus 25 divided by 25, and that's that right there. Do not cancel those out because, for example, let's say if it was 1 plus 25 divided by 25, that would be equal to 26 over 25. So do not cross out the 25s because this does not equal 1. That is not the same thing. So this has to remain like that. Okay, and doing the same thing over here. I'm going to combine those. So I'm going to multiply the top and bottom by x minus 1, multiply by 2, multiply by 2. Okay, so then I'm going to get 16 plus x minus 1 divided by my common denominator of 2 and x minus 1. And that's equal to x plus 15 over 2 and x minus 1. And that's all over 2 and x minus 1. So let's use a keep, change, flip. So I'm going to keep the top. So x plus 15 over 2 and x minus 1. Change the sign, flip the bottom, so x minus 1 divided by 2. Okay, and since it's multiplying now, let's just combine it. And I can cancel those out right there. So I have x plus 15 on top over 4, because those are going to multiply right there. Okay, let's solve these rational equations. So I have here 2 over x plus 8 and 5 over 2x minus 7. So these are equations, so I have methods of solving them. There's cross multiplication. So if there's one rational expression to each side of the equation, like here, not like right here, if that's the case, I can use cross multiplication. So I can multiply like that. So I'm going to multiply 2 to 2x minus 7 and 5 to x plus 8. This is just the shortcut method, right? And then I'm going to distribute, so it's going to be 4x minus 14 equal to 5x, and then 8 and 5 together is going to be 40, so plus 40. I'm going to subtract 4x. Okay, so I got negative 14 is equal to x plus 40. I'm going to subtract 40. Looks like I'm going to have x is equal to negative 54. Okay, for 18, cross multiply, so x to x, that's going to give me x squared equal to negative 4 to those two terms, so it's going to be negative 4x minus 4. It is a quadratic, so let me get everything on one side. So x squared plus 4x plus 4 equal to 0. I'm going to factor my quadratic, so that's going to be x plus 2 and x plus 2 equal to 0. So then I'll have x is equal to negative 2 as the one and only solution there. Okay, for 19, I can't use cross multiplication here because I have two rational expressions on one side rather than one rational expression and one rational expression. So instead, I'm going to use my least common denominator. So in this case, I have x and x plus 2, so those multiplied together make up my least common denominator. Okay, so whenever I multiply this, remember I multiply to the numerator each and every numerator. Okay, so as a quick example, that's going to give me 4x times by x plus 2 divided by x for my first term. But the x's are going to cancel. So then I'm just going to have 4 and x plus 2. Okay? Now I don't have the x in the denominator because I don't want x in the denominator. Now I'm going to multiply the least common denominator by this 1. Now it doesn't have a denominator to cancel anything out, but that's okay. So I'm going to do negative, I'm just going to, so x and x plus 2. There you go. Equal to, now when I multiply the least common denominator with my last term, that's going to be 4 times x times by x plus 2 all over x plus 2. And you can see that the x plus 2's are going to cancel, so I'm just going to have 4x. So again, I've eliminated all my denominators, which is great. I don't want x's in my denominators. And then I'm going to solve it. I'm going to distribute that 4, so I'm going to get 4x plus 8. Distribute the negative x, so I'm going to get negative x squared minus 2x equal to 4x. You can see, well, let me combine like terms, but I'll have negative x squared. And then looks like I'll have plus 2x, and then plus 8. Okay, and since it is a quadratic, I want everything on one side, and I also want x squared to be positive. So I'm going to add that, subtract, and subtract. So I'm going to have 0 on the left side equal to positive x squared. When I subtract the 2x with the 4x, I'm still going to have 2x, but then I'll have minus 8, and then I'm going to factor this. So adds to be 2, but multiplies to be negative 8. So it's going to be plus 4 and minus 2 equal to 0. So that means x is going to be equal to negative 4, and x is going to be equal to positive 2. And that works. Make sure that they check out with the denominators here. I can plug both those in and not get 0. Okay, now let's get multiply by the least common denominator here. That's the method we want to shoot for. Now I am not going to multiply this by x squared minus 2x times by x minus 2 times by x. I do not want to do that because if I factor this denominator, I'll see that I can take out an x and I'll have x minus 2. And you can see that this denominator consists of the other two denominators. So all I need to do is multiply by what they have in common. So my least common denominator is x and x minus 2, since every denominator consists of one or both of these factors. So if I multiply it through, so if I multiply this by the numerator, those are going to cancel with its entirety, so I'm just going to be left with 12. Then I have minus 3. Okay, when I multiply this term by my least common denominator, the x minus 2's are going to cancel, and I'm just going to have 3x, so minus 3x. I guess I don't need those parentheses, but so just 3x equal to 3. When I multiply this by my least common denominator, the x's will cancel, but I'll have the x minus 2. Okay, so I have 12 minus 3x equal to 3x minus 6. That's combined like terms, so let's see, I'm going to add a 3x, and then I'm going to add a 3x here. So I'll have 12 is equal to 6x minus 6. I'm going to add a 6 and add a 6. Okay, and then I'm going to have 6x is equal to 18 divided by 6, so x is going to be equal to 3, and that does check out. Alright, let's try 21. So again, least common denominator. I'm not going to multiply by all three of these. Instead, I'm going to factor this, and I'll see that when I factor it, it consists of the same factors that are here. So my least common denominator is the product of x minus 4 and x minus 1. Okay, I'm going to multiply this by the far one over here. The x minus 4's are going to cancel, so I'll have x plus 6 times by x minus 1 minus 30. Because when I multiply this whole term by my least common denominator, it's going to cancel. Those are going to cancel. And that's going to be equal to 3, and then I'll have x minus 4. So when I multiply those together, those are going to cancel. Okay, let's FOIL it out. So I have x squared plus 5x minus 6 minus 30 equal to 3x minus 12. when I reduce or combine like terms, I'm going to have minus 36, and that's going to be equal to 3x minus 12. I'm going to want to add 3x to this. I'm going to want to add, subtract 3x from that. So subtract 3x, subtract 3x. I'm going to want to add 12 and add 12. Okay, so I have x squared, and that's going to give me plus 2x, and that's going to give me minus 24 equal to 0. Let's factor this. Two numbers that multiply to be negative 24 and add to be 2. That's going to be equal to plus 6 and minus 4, I believe. Okay, so x is equal to negative 6 and x is equal to positive 4. Let's make sure that those work out up here. Okay, notice my denominator, x cannot be equal to 1 and x cannot be equal to 4. So this right here will not work. Only this one right here. Alright, for 22, one last time, we're going to factor this out right here because I'm not going to multiply by x squared minus 3x minus 10. If I do factor this, I can see that they are indeed the factors of that these ones are right here. This is what this factors into. So my least common denominator is x minus 5 and x plus 2. Okay, so multiply by every term. When I multiply it by over here, I'm going to have x and x plus 2 and x minus 5 equal to 11. Okay, and then I'm going to do x squared plus 2x plus 2x minus 10 equal to 11. So I have x squared plus 4x. And since this is minus 10, I'm going to subtract 11 from that. So it's going to give me minus 21 equal to 0. Let's factor this. So two numbers that multiply to be negative 21, but we'll also add to be positive 4. Sounds like that's going to be plus 7 and minus 3. So x will be equal to negative 7 and x will be equal to positive 3. Make sure that they work up here. So x cannot be equal to negative 2 or positive 5, which is neither of these numbers. So there you go. Okay, so there is the very quick fast-paced key to this. Just make sure if you guys need to pause through any of that or revisit any of these problems that I did, go for it. But hopefully it helps.